In number one, we're going to begin by factoring the denominator. That's the way we always start these partial fractions integration problems. So here we have x plus 2, x minus 2. So that's two linear factors. So we're going to break up this fraction as follows. We're going to have one fraction with denominator x plus 2 and another fraction with denominator x minus 2. Okay, that's because both of these have only multiplicity 1, exponent 1. So one fraction per factor. On top of a linear, we put a constant. All right, on the left, I'm just going to copy over this integrand. Now, this is an identity. The right-hand side is an alternate form of the left-hand side. That's why I put this rather than an equal sign, I put an identity sign. All right, now we're going to multiply both sides by the denominator, by x plus 2 times x minus 2. And this side as well. So on the left-hand side, we just have the numerator, x minus 1. And on the right-hand side, when we multiply through, the x plus 2's cancel. And when we multiply the second term, the x minus 2's cancel. I'm not always going to write this identity symbol. Sometimes I'll switch to the equal sign, but you'll know what I mean, that these two are identities. That this is an identity. Both sides are identical polynomials. All right, let's multiply through on the right. So on the left we have a polynomial beginning with x, and on the right we also have a polynomial, and now we're going to do what we call equating coefficients, putting the coefficients equal to one another. First, the x coefficient on the left is 1, and on the right it's a plus b. So that's one equation. And then we're going to have an equation based on equating the constants. The constant on the left is minus 1. And on the right, we have minus 2a plus 2b. So here we have two equations and two unknowns. We're going to solve this by combining the two equations, and we would like either the a's or the b's to cancel when we do that. So if we multiply both sides of the top equation by 2, then we'll have a 2a here, and here we have a minus 2a, so when we add that, they'll cancel. So let's do that. Let's multiply both sides by 2. So here we have 2 is equal to 2a plus 2b. Now I'm going to copy over the second equation. And now add the equations together, because now we'll get this canceling, and we'll be left only with b in the equation. So on the left side we have 1. And on the right side, 4b. So solving for b, we have b is equal to 1/4. And now we have to just substitute in, let's say right here, substitute in 1/4 for b, and we'll get a. So if we subtract 1/4 from both sides, we have a is equal to 3/4. So now we have a and b. So what we're going to do is just substitute a is 3/4 in this expression, and b is 1/4. And we'll rewrite our integral. Rewrite this as 3/4 over x plus 2 plus 1/4 over x minus 2. Okay, so the integral of x minus 1 over x squared minus 4 is equal to the integral of 3/4 over x plus 2 plus 1/4 over x minus 2 dx. And now we're ready to integrate. This one's a log and this one's a log. We'll integrate term by term. So integrating the first term, we have 3/4 log x plus 2 in absolute value. And for the second term, we have 1/4 log x minus 2 in absolute value. In number 2, we have an integral where the denominator is already factored. So we'll start by breaking this up into partial fractions. So we write x plus 1 over x times x plus 2 squared is equal to, okay, so we're going to have one fraction with denominator x, and x plus 2 has multiplicity 2, so we have two fractions for denominator x plus 2, one with exponent of 1 and the other one with exponent 2. These are all linears, so on top of linears we have constants. And now let's multiply both sides by the denominator. X times x plus 2 squared on both sides. So on the left we have this numerator x plus 1. And on the right we have a times, okay, first the x's cancel, so we have a times x plus 2 squared plus b times, and now the 1 x plus 2 cancels, so we're left with x times x plus 2. And now the x plus 2 squared cancels, so we're left with cx. All right, we want to multiply this out, so here we have a x squared plus 4x plus 4. And here we have multiplying through by bx squared plus 2bx. All right, so let's multiply through by a. So here we have ax squared plus 4ax plus 4a plus bx squared plus 2bx plus cx. On the right we have a polynomial of degree 2, on the left degree 1, so that means that on the left the degree 2 coefficient is 0. So on the left we have a 0x squared here in front. Let's equate the coefficients of x squared. So on the left we have 0, and on the right we have coefficients of x squared. We have a plus b. All right, now let's equate the coefficients of x. On the left we have a coefficient of 1, and on the right we have 4a plus 2b plus c. All right, and now we're left with the constant coefficients. On the left we have 1, and on the right we have 4a, just 4a. So from this equation we conclude that a is equal to 1/4. All right, now here if a is 1/4, we have that b is minus 1/4. All right, and now we can use this to find c. So remember, a is 1/4, and b is minus 1/4. So here we have 1 is equal to 4 times 1/4 is 1. 2 times minus 1/4, that's minus 2/4 or minus 1/2, plus c. So we have 1 is equal to 1/2 plus c. subtracting 1/2 from both sides, we have that c is equal to 1/2. All right, now we can put this together back to our partial fraction decomposition. A is 1/4, B is minus 1/4, and C we have 1/2. So let's rewrite this. Okay, this integral that's our original integral is equal to the following: 1/4 over x plus minus 1/4 over x plus 2 plus 1/2 over x plus 2 squared. And we're going to integrate term by term. This is a log, this is a log, and here we just use the power rule. So we have, for the first term, we have 1/4 ln x, and for the second, minus 1/4 ln x plus 2, and for the third, we have plus 1/2, and we're just going to do a power rule. I'm not going to do a u substitution, because if I put u equal to x plus 2, du is equal to dx, so I can use the power rule directly. Here we have x plus 2 to the minus 2, so we're going to add 1, and divide by the new exponent. In number 3, we'll start by factoring the denominator. Just factor out an x. All right, notice that this quadratic can't be factored further. B squared minus 4ac is equal to 4 minus 4 times 1 times 5. That's negative. All right, so let's break this up. So we have 3x squared plus 4x plus 5 over x times x squared plus 2x plus 5 equal a over x plus bx plus c over x squared plus 2x plus 5. All right, and now multiply by the denominator, both sides. So we have 3x squared plus 4x plus 5 is equal to a times x squared plus 2x plus 5 plus bx plus c times x. Okay, multiplying through, ax squared plus 2ax plus 5a is equal to bx squared plus cx. Okay, now we're ready to equate the coefficients, starting with x squared. So we have 3 is equal to a plus b. And now the x coefficient. Okay, so we have 4 is equal to 2a plus c. And now constant, we have 5 is equal to 5a. All right, so we get that a is equal to 1. Let's put that here. And we have b is equal to 2. Okay, again, a is equal to 1. So that means c is equal to 4 minus 2. c is equal to 2. All right, so we're ready to substitute in our values for a, b, and c, 1, 2, and c is equal to 2. All right, so we're going to integrate 1 over x plus 2x plus 2 over x squared plus 2x plus 5. Okay, the first one's a log x. And notice that in the second term, the derivative of the denominator is 2x plus 2, which is exactly the numerator. So this is also a log. Derivative of denominator is 2x plus 2, and that's equal to the numerator. So that's exactly the log of the denominator. Okay, that is log x squared plus 2x plus 5. And number 9 will right away break up in partial fractions. The denominator is already factored. So let's do that. So we have 3x cubed plus 2x squared plus 18x plus 9. And we're going to break this up into, here we have multiplicity 2. So we have one fraction with denominator x, and another one with denominator x squared. And here we have a quadratic, so we put a linear on top. Okay, and then multiply by the denominator. On both sides. Okay, so here we get the numerator. And here the x's cancel and we have ax, x squared plus 9. Here the x squares cancel, we have b, x squared plus 9. And here we have cx plus d times x squared. Okay, let's multiply through. And here we have ax cubed plus 9ax plus bx squared plus 9b plus cx cubed plus dx squared. Let's equate x cubed coefficients. 3 equal a plus c. Now x squared. 2 equal b plus d. And now x 18 is equal to 9a. And finally the constant. 9 is equal to 9b. Okay, so b is equal to 1. A is equal to 2. Okay, so let's put that in. So here we have a is equal to 2. So we have c is equal to 1. And b is equal to 1. So here we have d is equal to 1. We're ready to fill in. So let's do that. So b is 1. A is 2. C is 1. And d is 1. Okay, let's write down our integral. 2 over x plus 1 over x squared plus x plus 1 over x squared plus 9. Okay, so we're going to integrate term by term, but we'll split this one up. Okay, so we're going to have the integral 2 over x plus 1 over x squared plus x over x squared plus 9 plus 1 over x squared plus 9. Okay, so here we have a log. Here we have a power rule, x to the minus 2. So that'll be minus 1 over x. Okay, that is x to the minus 2, add 1, we have x to the minus 1 with a negative sign in front. Okay, here we have a log again. Derivative of the denominator is 2x, we're just missing the 2. So we have 1/2 log x squared plus 9. And here we have an arctan. So this is a squared is 3 squared, so that's 1/3. Arctan x over a, that would be x over 3.